Hello, hello everyone. And we're going to be looking at the parts of a volcano, the the different features of a volcano, and yeah, that's basically it. Now, first, we'll be looking at what is a volcano. Now, volcano, as I said in the previous video, is an opening or a rupture in the Earth's surface or crust, and it would allow hot molten ash and gases to escape from deep below the surface. Now, volcanic activities, right, it tend to form mountains or features over a period of time, right? Now, a typical volcano, right, it's normally conical, and at the top is normally called a crater. And of course, you have the vent and you have the different parts of the volcano, right? Now, I'll be drawing a volcano. Do not mind the drawing since I cannot draw, but I'll be trying to demonstrate the parts of a volcano, right? Right? Now, just pretend that, just look at the information and not at the drawing, right? So I'm drawing here, I'm drawing my vent here. Right? 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 So pretend that this area that I'm coloring right now, pretend that these areas, there are layers of rock, right? So these areas right here, these layers that I have indicated, these are layers of rock, right? So assume that they are layers of rock, right? Layers upon layers of rock, right? There are layers of rock because you have the constant cooling and hardening of lava, right? So this is basically a typical volcano, right? Let me just draw something else here. Good. Okay. Okay. All right. So that's basically it, right? Now I'll be labeling these parts of a volcano. Right? This. I'll be labeling this right here. Mm-hmm. Yeah. Good. Right? Now, this area right here is what we call a pyroclastic cloud, or you could say ash cloud, but I rather the term pyroclastic cloud. This is because you have basic different types of pyroclastic material. So you have the pumice, you have the cinders, you have the volcanic ash. All of this, or you have the gases, you have everything in this cloud right here. Then the next component is what we would call the crater, right? So this is the opening, right? Then you would have the volcanic bomb, right? Volcanic bomb. Then this is what you would call the main vents. Then here, at times you would have a little, like a little volcano growing at the side. So this is what you would call a secondary cone, right? and then you would have a secondary vent. Right? And sometimes you would have the lava flow right here. So this would be the lava flow. And sometimes you'd have pyroclastic flow, like the different rocks and stuff, right? Now, this is basically the part of a volcano, right? The parts are the components of a volcano. You also have, last but not least, you also have the magma chamber. Now this is where all of this material come from, the lava. This is where all of it come from. Let me leave it right here, the lava, right? So this is where all of this comes from, right? Now I'll be looking at the features of a volcano. Now first, why do volcanoes cluster along narrow belts? Narrow mountain belts, right? No. Volcanoes cluster in these zones because this is where folding and the fracturing of the crust provide channel ways for the escape of lava to the surface, right? Now, these areas are normally located among plains margins, and basically, I think this is a very straightforward definition, right? Now we'll be looking at the features formed by volcanic activity. You have intrusive features and you have extrusive features, right? Now, the intrusive features, right, of a volcano. As I said before, this is where you would have like the magma. This is where the magma comes in, right? Because this is basically when the magma would cool and harden, and it would still be inside of the volcano. And sometimes this would be, right, this would be exposed. This would be like exposed on the surface at times because of constant weathering. But the first feature that we'll be looking at is what we call a dike, right? Now, a dike is basically when they're formed when so it's a mass of vertical or a highly inclined, right, intrusive rock. So it cuts along the areas or the layers of sedimentary rocks. All right, so let me draw the volcano here. Let me draw the volcano. Now, this, as I said before in the labeling of the parts of the volcano, you would have different layers of rocks, right? Different layers like this of rocks, right? Now, what happens with a dike, right? What happens with a dike is that you would have these different layers, right? So you'd have these different layers, right? These different layers of rock. So say this is 3 different layers of rock, and then you would have this rock or this layer of magma just going through all of these layers of rock, right? Just going through all of these, right? So this is normally formed when magma forces its way through a fissure, a crack, or a fault, and it cools and it solidifies, right? So it forces itself. So it's like you have a crack. So you have a layer of rock here. It's like you have a crack right here. And so what would happen is that the the magma would force itself upwards, right, into that crack, right? So it's normally affected by denudation, and when it's affected by inundation, it may stand up as a ridge, and it's normally more resistant than the surrounding rocks, right? So this would be more resistant to erosion, not to erosion, to denudation, than to these areas of rock. Simply because this is an igneous rock and these are sedimentary rocks. So sedimentary rocks are more to be weathered, right? So they are more vulnerable to weathering or denudation, right? And this is how it's normally exposed on the surface because of the constant weathering of the surrounding rocks, right? Now, the next one that we're going to be looking at is what you call the sill. Now, this is basically the same thing. This is the same thing as the dike. It's just that it's horizontal, right? So these are intrusions of igneous rocks formed between bedding planes of rocks. So it's like you have these layers of rocks, right? Layers upon layers, upon layers, upon layers of rock. And then we use a different color. And then you would have like this. All right, let me use a different one. Let me use brown. And then you would have like this area of lava pushing through the bedding planes, right? So it's like this is the area of lava. So it's across, it's going across, right? So these are formed when the magma forces its way between the layers of sedimentary rocks. So sometimes, at times, like you'd have these layers, right? And it's like it's forcing itself between. So like it's forcing itself between these two layers, right? And forming a feature, right? And it can be of any thickness and it normally extends over a large area, right? So a sill is basically horizontal and a dike is vertical, right? The next thing that we're going to be looking at is laccolith, right? Laccolith. Let me write it down. Laccolith, right? Now, these are domes or lens of igneous rocks which have been injected between two layers of sedimentary rock, right? So basically this is what happens, right? Now you have these layers of rock, right? Oops. You have these layers of rocks, right? And then here you notice that this is being pushed up and this is pushed down because of the movement of lava. So therefore it will begin to look like this. It would begin to look like that, right? And this would be the area of lava, right? So it would look like that. Let me draw it a little better, right? Let me draw it a little better so you can understand the concept, right? Sometimes this can be the magma chamber, yeah. Right, so it forces its way between, right? And then it would form a hill-like structure, right? Oops. Yeah. You form a hill-like structure right here, right? So this would be all the magma, right? Now, they are formed, right? When the magma forces its way between the two layers of sedimentary rocks. So it causes the upper surface of the rock to arch up into a dome like this, right? And then well-formed laccolith normally look, they have flat bottom and a rounded top, right? They are sometimes eroded and they form hills and they form mountains. So normally when denudation take place, right? This area up here is eroded and then this part is exposed and it normally becomes a hill or a mountain, right? It doesn't have to be this low, it can be very high, right? No. Another part of intrusive feature that we'll be looking at is placolith, phacolith, right? Phacolith, I should say. P-H-A-G, sorry, P-H-A-C-O-L-I-T-H, phacolith. Now, these are lens-shaped mass of igneous rocks, which are formed on top of anticlines or the bottom of synclines, folded in strata. All right, so you might not understand this definition. Let me explain it to you, right? So it's like you have these layers like this. Good? All right, let me draw it a little better. Yeah, these are more easier. These are easier to understand, right? Good. And what would happen where you have the pacholith, then you would have areas like these. So like the sinking area. Oops. Undo that. Okay, right there. Right there. Right there. Right there. Right there. Right there. So where I'm marking now, those would be the areas of lava, the areas of magma, right? So they are normally lens shaped. So just like how you have a lens, right? A lens we use, right? So just like how you have a lens with a like this, they are lens shaped. So therefore they're small, right? They're very small, right? Small like this, right? Make it a little bit better, right? So they are lens shape, right? Right? And they are formed on top of anticlines. Now, this part is what you would call the anticlines. So if you notice, they're formed on top, and then they're formed at the bottom of side synclines, right? So synclines, anticlines, synclines, anticlines. You may not understand this, right? So they're normally lens shaped. Just remember that they're lens shaped and they're formed on top of anticlines and at the bottom of synclines, right? In folded strata, right? So basically form below these parts right here. So just if you don't remember this, just draw it like this and form it on top here and below here, right? Now the next feature that we're looking at is batholith. right? Batholith. No, batholith is normally, it's the easiest one to describe because every single volcano has a magma chamber. Now, what happens is that this magma chamber, right? So remember when you're drawing the volcano, pretend that a vent is here. Like you have a vent right here, and then you have the magma chamber down here, right? So every single volcano has a magma chamber, right? Now this magma chamber, it would cool and it would harden and it would form this large area of igneous rock. Now when it's exposed to the atmosphere, it's because of the effect of denudation, whereas the surrounding sedimentary rocks would be weathered, right? So they often have an irregular shape, and they normally consist of coarse grained rocks such as granite or quartz diorites, right? So they have sides that normally inclines steeply. Now, all of these features that I have shown you, they are normally, if they're exposed outside or on the surface of the earth, then they would be exposed due to the process of denudation, which involves all the processes in which but in which materials are broken down, or in which materials are weathered, or in which materials are moved from one place to another, right? So denudation, basically, you would understand what I mean by denudation if you watch the previous video on weathering, right? Well, denudation, a component of denudation is basically weathering, and a component of denudation is mass wasting, right? So another feature, all right, the last but not least, you have the lapolith. Lapolith, right? Now, the lapolith is a basin-shaped body of igneous rock formed by the penetration of magma between existing layers of rock. So basically, you have a layer of rock like this, right? Now, the lapolith would behave like a layer of rock, and it would be between it. So it's basically a layer of rock. It acts as a layer of rock. So it's basically going between the layers of rock, right? And it's normally shaped like a base. It's shaped like you would have an area of rock. It's basically an area of magma, right, that would harden and cool and become an area of rock eventually. So lapolith, right, it's basin shaped, right? And it forms between the layers of sedimentary rocks where it would penetrate, right? Now, as for the others, they also are exposed by denudation, right? Now, we'll be looking at extrusive volcanic features. Now, materials ejected onto the Earth's crust may form a number of features or landforms. The shape of the landform depends on the nature of the rock ejected, right? So of course, and it also has an effect on the type. It's affected by the type of lava as well, whether basic or acidic. Now remember that basic would be fluid lava and acidic would be viscous lava. Now you have an ash cone volcano. Ash cone volcano. So it's basically a volcanic cone that is built because of unconsolidated dash. Right? So unconsolidated ash. Right? So they are formed by the interaction between magma and water. right? Such as those occurring on the open ocean, right? So the interaction between magma and water, along with the expanding steam, it would then produce the ejection of gas, of ash, right? Now the ash that falls after an eruption, it forms a cone, a ash cone. So basically, what happens is that when magma and water meet, right, they would produce steam, right? In producing steam, then the ash would then fall onto the crate, onto the slope of the volcano, then producing an ash cone, right? Now, ash cones, they are normally like this, right? This is the crater right here, and yeah. So basically, they are not really steep. Now, an example of a ash cone volcano, you could say Diamond Head, right? Diamond Head and the Kapoho cone in Hawaii. Now, as I said before, the volcanic cone built particularly or primarily of unconsolidated ash, right? It means the ash is loosely arranged, right? It doesn't really have a particular arrangement. It's just loose, right? So that is ash cone volcano, right? Now we're going to be looking at cinder cone volcano, right? Now, cinder, I explained in the previous video, it's one of those pyroclastic materials that are ejected from the volcano, right? Now, it's normally a steep conical hill, and it's also called a scoria cone, and it's built typically on volcanic debris, right, or tephra. So it normally accumulates around a volcanic vent, right? Now the volcano forms when the volcanic debris, it pile up along the vent, and it forms a circular oval cone, right? Now the cinders are melted rock that has cooled, and it forms pebble-sized pieces thrown out. Now these are the most common kinds of volcanoes. So what happens? Let me draw it. What happens, right? Is that it's steep, fairly steep, fairly steep. It can be this steep, it can be a little more gentle, but it's fairly steep, right? And what happens is that all of these pyroclastic material that would come out of the volcano, it would then begin to form layers. So it's like you have this particular opening in the Earth's crust, right? This is the opening, and you have the magma chamber. So it's like this is erupting, and you have cinders which will fall out, or volcanic material that would form out, and then you form a layer right here, then it form another layer, then another layer, and this happens until it would grow into a large steep volcano, right? Now examples of cinder cones include the Cerro Negro in Nicaragua, or you could say the Crater Lake, Oregon, right? On Wizard Island. So Wizard Island, Crater Lake, Oregon, right? Or you could just simply say the Cerro Negro in Nicaragua, right? So these are basically layers of volcanic material, tephra, right? Layers of cinders. Good. Now this is what we would call cinder cone volcano, right? The next one that we'll be looking at is dome volcano, or you could also call it acidic lava dome or silicic silicic lava dome, right? So as we think about basic or acidic lava dome, we would of we would of course think of a very steep volcano, because you would always have the viscous lava cooling, because it would not get to travel large distances. All right, so you'd have this layer. All right, let me draw it down here. Let me draw it down here. You'd have this layer, right? And then you'd have this opening with the magma chamber. When the magma is forced up and it contains high level of silica, what would happen? It would, as it flow in here, it would just cool, because it cannot get travel large distances. Therefore, it just cool right there. The lava continues to move up. It would create another layer right here, another layer right here. It would continue to go up, creating another layer right here, another layer right here. Continue to move up, creating another layer. It's gonna happen again and again and again until it forms a very steep volcano, right? So the height of these volcanoes are normally greater than the width of the base. So the so the volcano is normally built by further addition of layers of lava, of cool acidic lava, as I showed right here, as shown right here, as I demonstrated earlier. And they're they're basically extremely, extremely steep volcanoes. Now sometimes some of the viscous lava, it would then squeezed out, right? And it would form a spine or a plug at times. And sometimes when it forms a spine or a plug, then right here would be clogged up. And this is why you would have more explosive eruptions because of viscous lava, because as it's going up into onto the earth surface, blocking right here, then you'd have the pressure building. When the pressure builds up, then it would just explode, because it's trying to come out, right? Now, areas with volcanoes with acidic lava, they tend to be extremely explosive, right? An example is the Sulphur Hills volcano in Montserrat, right? So this is an active volcano, right? So this is what you would call, I would call it dome volcano. Or if you want to remember it, you could call it acidic lava volcano, right? This is for those who want to remember it. I would use that one because it's easier to remember, right? Considering the whole principle of acidic lava. Good. Now, the next type of volcano that will be the next type of feature, right, is what we call shield volcano. Or you could also call it as basaltic lava volcano. I would rather calling it basaltic lava volcano. And you'll see why, right? Now, a shield volcano is normally a wide volcano, with shallow sloping sides. Now, this is normally formed by basaltic lava or basic lava. Now, remember that basic lava, they're highly fluid, they tend to flow very fast. So, therefore, you would have, so this is the earth, and therefore, you'd have like this layer, right? This is the layer. So basically, it would just be running off. So when the lava escapes to the Earth's surface, it would just keep on running off and running off and running off. You would barely have that much lava cooling and hardening. So therefore, it form a wide volcano. It would just look like this at times, or it can be steeper. After it can be steep like this after years upon years upon years, because this would take years, right? Basaltic lava volcano. These volcanoes normally take years, a lot of years to form, right? Extremely, because you would have a lot of running. It's like you'd have a lot of surface runoff of lava. So therefore, because of its low level of silica and because of its high fluid, it being highly fluid, then it would not have any time to like cool by the slope of the volcano. It just run off. Normally basic acidic lava volcanoes, they normally they normally they're built upon years, but they normally take less time to create a steep volcano than basic lava volcanoes, right? Okay, so example of these, you would say the Ertaal in Ethiopia. So that's Ertaal in Ethiopia. Ertaale. This is in Ethiopia, right? Let me erase right here. The next volcano that we'll be looking at is composite volcano or strato volcano. So composite or strato. Right, composite or strato, right? So these are normally tall conical volcano consisting of many layers of volcanic material, right? So they have a lot of layers, right? A lot, right? Right? So basically, you would have layer. All right, so this is the main vent. Then you have layer upon layer upon layer upon layer. So basically, they have layers of volcanic material, right? And they are constructed from multiple eruptions. So they normally take hundreds of thousands of years to make, right? So an example would be Mount St. Helens and Mount Rainier in Washington State, USA. So that's Mount St. Helens and Mount Rainier in Washington State, USA. You could also say Mount Fuji in Japan, Mount Hood in Oregon, USA, right? Now, the next type of volcano that we'll be looking at, oops, I took out one of them, but we know it, right? Okay, so the other type of volcano we'll be looking at is caldera, right? Now, a caldera is a large volcanic crater, especially one formed by a major eruption, right, leading to the collapse of the mouth of the volcano. So what would happen is that you'd have this huge, all right, so this is a volcano, right? This is a volcano. Pretend that a main vent is there, and you'd have this this large eruption, a very explosive eruption, and therefore all of this area, right, would collapse. Everything. So it's just left like this. Just left like that. Right? So all of this. And at times, so it's normally a wide opening. And at times when this forms a lake, you could say that it's wider than that. Yeah. The vent is normally wider than that. So it forms a wide vent. And sometimes, right, water would collect in this crater and it would create a crater lake. Right? Let me try to draw it a little bit better. Right? So I explained the whole caldera. I explained the caldera, right? Now I'm going to be explaining the crater lake. This is basically the water. So as I said before, the caldera is formed like when explosive eruptions. Why I keep saying erosion? These explosive eruptions where the top, right, collapses, right, and leaving a large vent. Right. So this is normally the water collecting. This is the water collecting in the crater. Right. This is what you would call the crater lake. So when the water collects in the caldera, is what you would call the crater lake. Now, an example of a crater lake is Crater Lake in Oregon, USA. Right? So that's easy to remember, right? Crater Lake, Oregon, USA. Good. Now, we'll be looking at the major volcanic forms, right? So you have four of them, right? So these are normally created by dormant volcanoes, right? The first one is hot springs, or we would also call it thermal springs, right? So it's normally a spring that is produced by the emergence of heated groundwater, right? And it's normally heated by geothermal heat. So it's like you just have it and it just spring out of the earth's surface. So it's like you have this groundwater being heated up by the magma, right? So basically, this is geothermal water. This is evidence of geothermal energy, right? You have a geyser. Now, this is a type of hot spring. So normally, all right, so this is a type of hot spring. So like you have this area and you have this water just splashing upwards. So that is what you would call a geyser. So if you remember in Dora, we would have the gooey geyser. Yeah, for those who used to watch Dora when they were smaller, where you have the gooey geyser, well, there's no such thing as a gooey geyser, but the same thing applies. It's just that instead of goo, it would be water. So basically, like how you see, like the water will be springing upwards out of the earth because of it being heated by the magma underneath, right? So that's what you would call a geyser, right? Good. Another type of feature is what you call fumaroles. No, I'm just gonna do both of them in one, right? Fumaroles. Fumaroles. Right? So It's an opening in the Earth's crust which emits steam, right? An opening in the Earth's crust which emits steam, gases such as carbon dioxide, sulfur dioxide, hydrochloric acid, and hydrogen sulfide. So basically, it's like you'd have this area of steam going upwards from the opening in the Earth's crust. This happens near volcanic islands. Now, I know everyone knows the movie Ice Age, right? No, fumaroles, they showed an example of fumaroles in Ice Age, right? Whereas Ice Age 2 specifically, where Eddie, right, that's the big mammal, right, he was trying to get to the boat, right? He was trying to get to an area. I don't remember where it was. He was trying to get to another side to help Ellie, who was trapped underneath some rocks, right? And then he came across this flat area, and it's like he had different holes, and it's like steam was ejecting from the opening, like they had openings, and like steam was rushing out of it. So that's basically a fumarole, right? You can make basically, if you think about it, yeah. So that's basically fumaroles. So it just was shown in Ice Age, right? You have So the most popular one you would have is hot springs and geysers. Those are the two most popular ones. All right, so you have wait, I'm coming. Sulfatera, right? Sulfatera. So these are natural volcanic steam vents that it continuously gives off steam and gases, particularly sulfurous gases. So it also could be demonstrated in Ice Age as well, right? So they're similar. They're very similar, right? It's the same thing like fumaroles, I should say. It's just that it would emit more gases, more sulfurous gases, right? Now we look at the positive effects of the positive effects of volcanic activity. So positive effects, and on this side we'll be looking at the negative effects. I'm just summarizing it, right? In the form of a table. Oops. Right? Positive effects, negative effects. Now, one positive effect of volcanoes is that the igneous rocks are valuable. Igneous rocks are valuable, right? Now, volcanic rocks, they're very valuable, right? For their minerals. They contain a lot of minerals. For example, nickel, copper, gold, right? Formed in Guyana. It's some of it is found in Guyana, right? So igneous rocks are normally those valuable rocks. So they produce those beautiful rocks, right? So and another positive effect is that weathered lava produces rich soil. So weathered lava produces rich soil, right? So in these areas, normally they support the minerals, because lava has a concentrated amount of minerals. Then when it hardens and when it cools, then those minerals would then create creates good rich soils full of minerals, especially when you have pyroclastic material, right, on top in those soils. Then it would be a rich soil for farming, right? So used as energy source, right? So the hot springs Hot springs used as energy source, right? So some spas or hot springs, they are used for health purposes, right? So sometimes they say this particular area, go to this area so you can get healing or whatever, right? Now geothermal energy. So a positive effect is geothermal energy. Whereas you would have the groundwater being heated by magma and then it going up and it would it would normally create electricity, right? They have a way of making it generate electricity, right? In some areas such as Iceland, they use this as a form of energy. No, tourism, right? So that's one positive effect. Now, volcanic features, they are normally famous tourist attraction. For example, when a dike or a sill or a batholith, right? It's when it's exposed to the earth's surface, right? They normally use those as tourist attractions. Or sometimes hot springs and those, they are normally tourist attractions, right? Now, another positive effect, I'll not write it down, but mud rich in black iron sulfide, it's used in soap manufacturing in Dominica. Now, Dominica also exports pumice, which is volcanic rock. Right? So now we'll be looking at the negative effects. Now, of course, the first one that we would think of, lives lost, right? So this is volcanic activity. We know it causes loss of life, right? Now, another negative effect is when the ash and the mud from the volcanic eruption, when it mixes with the rainwater, right? Or snow, right? Now, fast moving mud flows are created. So when it mixes with rainwater and it mixes with mud, so they create fast moving mud flows. Another disadvantage or another negative effect, it destroys settlements and it destroys areas of agriculture and woodland. So it destroys settlements and cultivation areas. Right? Oops. They're in bold there. Well, good. Last but not least, human and natural landscapes are destroyed. Yes, so like you have this beautiful forest right here, and then the volcano erupts, and all of that is damaged, right? So human and natural landscapes are destroyed. And sometimes these can be destroyed forever because sometimes the lava can also burn into the soil and then you'd lose nutrients from the soil. Therefore, no plant would grow there, and therefore no animal would grow there, and no farming happens there. So that's what happens. So thank you for watching this video. I hope you understood the key factors or the key points, and I hope that you learned something. Thank you for watching.